In this video, I will be solving the paper 1 question for kinetic particle theory, which is the first chapter of O-level syllabus. Topic is states of matter. We call it kinetic particle theory as well, and the code is 5070. Let's start it. The first question is the diagram shows some of the changes of state. A triangle is given where we have solid, liquid and gases, and arrows are marked as 1, 2, 3 and 4. The question is which statement is correct. So among all the 4 options, we're going to check which one is the correct option. Although the change is not shown on the diagram, a gas can change directly to a solid. If we see between solid and liquid, between liquid and gas, all the changes has been marked. But in solid to gas, we see only one change has been marked, whereas we know that there is a possibility that gas can change back into solid. So yes, that can be the correct option, but in O-levels, I always instruct my students not to go with the very first option that you have read and you thought that, okay, this is correct, तो यही mark कर देते हैं. I always suggest them, beta, even though you are very much sure that the first option is correct, you should go and read all the 3 options, rest of the 3 options. So you are very much sure that you have got the question correctly. So A statement is correct, but we are not going to miss the rest of the 3 statements. We will read and I'll explain that what are the meaning of the rest of the 3 statements. The change 1 and 3 involve particles moving closer together. So 1 is solid to liquid, that means it's melting, and 3 is where gas is changing into liquid. When solid changes into liquid, the particles are moving far away from each other. So this statement is incorrect, because in one where melting occurs, particles move far away from each other. So we cannot go with option B. In option C, the change to which is liquid to gas is boiling or evaporation. Particles are moving apart. Yes, it's correct. But what about 4? The 4 says that liquid is changing into solid. So whenever liquid changes into solid, the particles go closer to each other, not go far. So even Charlie is wrong. The delta option says the changes 3, 4 and 5 all involves the release of energy. 3 option is when gas changes into liquid, that means condensation. So in condensation, energy releases, yes. In 4 process, liquid changes into solid, that means freezing occur. And in freezing, the particles come closer, they release energy. Yes, it's correct. And in 5, it says that solid changes into gas. That means energy is being absorbed because it is a sublimation process, and in sublimation heat is being absorbed. So delta option is also incorrect. So that is why we have chosen option A, because the change is possible from gas to solid even though it is not shown in the diagram. Okay, the next question is the diagram shown and apparatus used to compare the rates of diffusion. So this question is definitely related to diffusion. At which labeled position did a white deposit of ammonium chloride is formed? So before we start, I would like to explain that you should know whenever ammonia and hydrogen chloride gas reacts, white fumes of ammonium chloride is formed. So as you see, there is a glass discharge tube where on one side ammonia gas, a plug soaked in ammonia gas is placed, and on the other side a plug of cotton soaked in hydrogen chloride gas is being placed over there. As soon as we place both the cotton plugs, the gases will start diffuse from their cotton plugs, because there is more concentration. So in diffusion, we know that particles move from the high concentration to the low concentration. So in the plugs, the concentration of ammonia and hydrogen chloride is more, so they start moving away from their cotton plugs towards the low concentration. As you can see on the screen, ammonia gas has a molecular mass of 17. I have calculated over here, so you can see how you calculate. And hydrogen chloride gas has a MR of 36.5. Their MR clearly shows that hydrogen chloride gas has a high molecular mass. That means it is heavier molecule, so it is going to diffuse slower. And ammonia, which is a lighter gas, so it is going to diffuse faster. So if I see the middle of my tube is this point, Charlie. Of course, they are not of equal MRs and they are not going to meet in the middle of the tube. They are going in the test tube to the edge which is far from ammonia but closer to hydrogen chloride gas. So that makes D a correct answer. And the next question is again from the topic diffusion, where you see that we have ethylamine, which has a formula given, and hydrogen chloride with the given formula react together to form a white solid. And white solid is ethylamine hydrogen chloride. You don't need to bother about this name, because most of the time in the question paper they are going to give very difficult situations, very difficult names, very difficult formulas just to confuse the students. You just focus which concept is being used and ignore the difficult picture diagram which is given, or a difficult reaction or a difficult name, because that is just to confuse you. So our concept used here is about diffusion. You need to see that this is a concept of diffusion which is being used and discussed. So question is, at which position in the tube would a ring of solid white ethylamine hydrogen chloride is formed? Again, you have to calculate the MR, which I have calculated for you. And further in the topics where I'll be teaching you the atomic structure, calculating the atomic molecular mass from the atomic mass, you will easily learn how to calculate MR. So right now, if you haven't studied about calculating molecular mass, please don't stress yourself. Just focus on what I have done for you, that MRs are being given. You just need to compare the MRs and calculate and critically analyze that what should be the answer. As you see that ethylamine gas has a more MR of 45 and hydrogen chloride has an MR of 36.5. That means the fumes are going to travel in such a way that a white ring is formed to the end further away from hydrogen chloride gas, because that has a lower MR as compared to ethylamine. So that definitely my answer is going to be not delta, not Charlie, and not Bravo as well, because Bravo is the center of the tube. They are not going to meet at the center anyways, because they don't have the same MR. So they are a little different MR. So alpha is going to be my answer. Because alright, in this question they are asking, when drops of bromine are placed on a tabletop at one end of a room, the smell of the bromine can eventually be detected at the other end of the room. So what is not part of the experiment of this? What is not part of the explanation of this? Sorry. So not, I have highlighted and underlined not. You do the same while you are attempting paper 1. Always keep a pencil in your hand and underline the important terms or the words you think that is going to help you to approach to the correct answer. I always instruct my students that underline the major or the important terms and the lines and the words in the question, so that helps you a lot in evaluating and approaching to the correct answer. Here not is very important, because you have to look for the wrong option, not for the correct option. That 4 statements are given, you have to look which statement is incorrect. So in this case, after evaporation, bromine particles, alphas collide with air particles. Yes, bromine, because it is diffusing, and in diffusion particles do collide with each other and with the air particles. It is correct. Bravo says move in a random way. Yes, diffusion is a very good example that justifies and proves the kinetic molecular theory. So in diffusion, yes, particles move randomly. Bravo is correct. Charlie says spread out to occupy the total available space. It is definitely correct, because in diffusion, the particles do move randomly and do collide and spread out to occupy all the available space. And delta says they vibrate from side to side. That is incorrect, because vibration of the particles occur only in the solid and not in the liquid and gases, because in liquid and gases the particles have spaces and they move away from each other, they collide. But in solid the particles vibrate. So definitely bromine is a liquid, it is not a solid. So the answer is going to be delta, because this is an incorrect statement and that is what we had to select. This question is asking that which process provides the best evidence for the particle theory of matter. To know the answer, you should first know that what is a particle theory of matter. Actually, kinetic molecular theory is another name for particle theory of matter, that states that matter is made up of tiny particles which are in the constant random motion. So we have to find out that which of the following processes is a justification or a explanation or a evidence for kinetic particle theory, or in very simple words, in which of the following processes the particles are moving and diffusing randomly and are in the constant state of motion. Dehydration is a process in which we are evaporating a substance, where we are removing water, and that is a physical change. In diffusion, the particles are moving from high to low concentration by random motion and collision. So that is the correct answer, but I'm not going to leave the rest of the two options. I will explain why the option C and D is incorrect. Filtration is a physical process where we are separating the insoluble from the soluble one. And delta says neutralization, that is actually a reaction of acid with alkali and bases, that is a chemical change. So among all the four options, Bravo is the correct option, because that is the option which is explaining that matter is made up of particles which are in the constant random motion. Okay, this question is again using the concept of diffusion, where we study that particles move from the high to the low concentration, and those particles which are having high MR are diffusing slower as compared to the particles which are lighter in weight or have less MR. And there are 4 balloons given, and you have to find out that these gases have been filled in the balloons, and which pair of the balloon will deflate at the same rate. Deflate at the same rate means those gases are diffusing out of the balloon at the same rate. So those gases which are having the same MR are going to have a same rate of diffusion. I have calculated the MR for your convenience. You see ammonia as having a MR of 17, carbon dioxide 44, C2H4, which is ethene, is having a MR of 28, and N2 is having a MR of 28. So that means the ethene and nitrogen are having, R and S balloon are having the same MR. So we have to look for the option where we are given R and S, that is Charlie definitely. So Charlie is the correct answer. Here we see 2 questions again using the concept of diffusion. I have calculated the MR for you, and they are asking which statement explains why the 2 gases blah 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 diffuses at the same rate, and you have to go with the option where they are saying that both the gases have same MR or molecular mass. The next question asks us that a drop of the liquid bromine is placed in the bottom of the gas jar. Brown fumes of bromine vapor slowly spread through the covered gas jar. Why does this happen? Slowly spread through the covered gas jar means they are again asking or using the concept of diffusion. Why does this happen? Of course, we know in diffusion the particles are in the constant random motion. So let's see which option is correct. The alpha option says that bromine vapors is less denser than air. No, we don't know the density of air right here in the question, and neither of bromine, so we can't say anything. Bromine molecules are the molecules in air are always moving around. Charlie says bromine molecules are smaller than the molecules in the air, and the delta option says bromine molecules move faster than the molecule in the air. as we are using the concept of diffusion, and in diffusion we know that particles are moving randomly and in the constant motion. So here in Bravo option they are using the concept of movement of particles all around. So Bravo is definitely the correct option. This question again uses the concept of diffusion, but the basic chemistry in this which you have to understand is how this works. As you see that there is a porous container which is being covered with the inverted beaker. So the beaker is not closed from the bottom. That means air can enter and go from this open end, and this porous container contains oxygen. Now what is our question? Our question is which gas when present in the beaker over the porous container will cause the water level at Y to rise. Now where is Y? Y is here on the right hand side of the tube. This has to rise, and this will rise when oxygen is being pushed down from this opening, and oxygen can be pushed down only in one condition: if the lighter gas is present in the beaker which enters into the porous container and pushes oxygen downward, so that in return pushes the water at the Y end upward. So water in the Y end will rise only if the beaker is containing a gas which is having a MR less than oxygen. So oxygen has a MR of 32, which I have calculated for you, and let's see in the options we have only one option which is Charlie that has a MR less than oxygen. So definitely Charlie is going to be the answer. Alright, this question is using the concept of cooling the liquids, cooling the gases. When the gases cool down, they are condensed and form the liquids. So here in the question, they are telling us the boiling points of various gases in the air, and they are saying if the air is cooled, the water is the first substance that condenses. Okay, to understand this question, you have to understand the concept that the boiling point of the substances are the same temperature at which the substance is going to condense. Yes, this is extremely important for you to understand. That means that water when boils at 100 degrees centigrade, when we are cooling the vapors, it cools down, and the water vapors will start the water vapors will start condensing to form liquid water at 100 degrees centigrade when we will cool it down. So the table which is giving us the boiling points of the gases are definitely the temperatures at which it condenses back. So I have drawn this graph for you. If you see from 0 to downward when we cool the gases, so carbon dioxide is the first gas which is going to be condensed. The reason is at -78 it boils off. So of course when we are cooling it down, so at the same temperature it will condense back. So the answer is going to be Bravo. Alright, this is the last question of this video, and the question says that what correctly describes the molecule in a very dilute sugar solution at room temperature. Again, what I have done, I have highlighted the words very dilute sugar solution. You need to understand what is a dilute sugar solution. Of course, we have taken some sugar and we have dissolved it in water. But dilute sugar solution means more water is being added and less sugar is being used. It is not a saturated or supersaturated solution. It is a unsaturated solution. That means it is having more water molecules than sugar molecules. So using this concept, you can easily approach the correct answer. Write down the correct answer in the comment box, and I will see whether you are able to approach to the correct answer, whether you have understood all the concepts, and I will definitely reply you to tell you that is your answer correct or not. Yeah, thank you so much. I'll see you in the next video. God bless you. Allah Hafiz.